Chapter 3, Section 1 is about lines and angles. So by the end of this lesson, you should be able to identify parallel, perpendicular, and skew lines, and identify angles formed by two lines and a transversal. So parallel lines are coplanar, remember that means on the same plane, and never intersect. So in this picture over here, we have a couple parallel lines, but as an example, line AB from here to here, and line EF from here to here. They're on the same plane, like this same piece of paper right here, but they're never ever going to cross. We use the symbol two like L's together to represent parallel lines, and we also show it on the diagram with these arrows going in the same direction. And then because these arrows here are going in the same direction, and there's two of them, we know those two lines are parallel as well. Perpendicular lines are lines that intersect at 90-degree angles, and we use like an upside down T for a symbol, which looks like a line with a perpendicular line going through it. So in the figure, line AB again, this one here, and line AE are perpendicular. This right here is a 90-degree angle. And I know it doesn't look like that in a picture, but think about what a cube would look like. And then they give you another example that from E to G and G to H, and that one definitely looks like a 90-degree angle. Skew lines are not coplanar, so that means they're not on the same like piece of paper, and they're not parallel, and they do not intersect, so it's kind of a combination of parallel and perpendicular lines. So in this picture from A to B, this one here, and EG, and now I know when we draw these and make them go on forever and ever, it looks like they intersect. But again, think about what a cube looks like. It would be this on the end of the cube and this on the front of the cube. And in real life, those are never going to cross. And then parallel planes are planes that do not intersect. So in the figure, ABE, plane ABE, which is like the top of our cube, and CDG, which is like the bottom of our cube, are never going to intersect. Remember, a plane's like a piece of paper that goes on forever and ever. So use this diagram. Identify each of the following. A pair of parallel segments. So we got a lot of arrows going on here, but remember, if they have the same number of arrows, they're all parallel. So everybody that has one arrow is parallel, and everybody with two arrows is parallel. So we could name from C to D, that has to be parallel to B, E. But it could also be parallel to FJ or GH. And all of those are parallel to each other. A pair of skew segments, remember, are not parallel or perpendicular, and they're not in the same plane. So let's use this front one right here, BE. Remember, this is on the front of a cube. And this is skew to anything that's not going to touch it, that's not on the same plane. So none of these will work, because those are eventually going to touch it. Let's get a different color. None of these are going to work. And none of these are going to work. This one right here would be parallel to it, so we can't choose that. This one right here, remember we said was parallel, and this one right here. So our only options are DH or CG. And all of those are skew. Pair of perpendicular segments, those have to make a nice 90-degree angle. So if we use BE again as our original, that's perpendicular to EJ or BF. And then a pair of parallel planes. Remember, planes are like sheets of paper. So let's use the front half of our cube. So we have plane BEF. And then the back of our cube is plane CDH. Remember, you just need 3 points, so you could have labeled it GCD, and it's the same thing. So now that we've talked about types of lines, let's talk about types of angles. So we have two lines floating out in space, and if those two lines are cut by something, we call that a transversal. So the definition is a transversal is a line that intersects two coplanar lines at two different points. So we have this line R over here, and this line S, and this T is our transversal. It cuts those two lines at 2 points here. And now what happens when we cut two lines in half, or somewhere in the middle, we get 8 different angles. And those 8 different angles are all very closely related, and we'll talk more about them throughout this chapter. But right now you need to know 4 different types of angles. The first one is corresponding angles. These lie on the same side of the transversal, on the same sides of line R and S. So same side of the transversal, so let's say left side of the transversal, and on the same side of line R and S. So the example they give us, 1 and 5, those are both to the left of T and top of R and S. So another example would be like 2 and 6. They're both to the right of T, but on the right side. Or like 3 and 7. Those are both on the left of the transversal, but they're on the bottom of lines R and S. Then we have alternate interior angles. And alternate interior angles are non-adjacent angles that lie on opposite sides of the transversal between R and S. So interior means they're on the inside. They're in this orange part right here. Alternate means opposite sides. So the example they give us is 3 and 6. 4 and 5 are also alternate interior angles. And then very closely related to that, we have alternate exterior angles. These lie on opposite sides of the transversal but are on the outside. So they're here and here. So the example they give us is 1 and 8. 2 and 7 are also alternate exterior angles. And then this next one should make a lot of sense. Same side interior angles. So the example they give us is 3 and 5. They're on the inside of R and S, but they're on the same side of the transversal. 4 and 6 are also same side interior angles. So use the diagram to identify each type of angle pair. Corresponding angles. Remember, those are the ones that lie on the same side of the transversal on the same side of lines R and S. So let's say we look at the left side of the transversal. This is on the top of this line that cuts through, and so is this. So angle 1 and angle 5. We also could have said like angle 4 and angle 8. They're on the same side, and they're both below our two lines. And then alternate interior angles. So we got to go inside, so we're looking in this portion right here. And we want them on opposite sides. So 4 and 6 can be options. But also 3 and 5 could be good options for that one. And then alternate exterior angles. So we're looking on the outside. We're looking here and here this time. And remember, we want them to be on opposite sides of the transversal. So angle 1 and angle 7 are good examples. You could have also picked 2 and 8. And then last one, same side interior angles. So again, we're on the inside of these two lines, and we want them to be on the same side. So like 3 and 6. You could have also picked 4 and 5. So hopefully this hasn't been too bad, but these are going to be the hardest ones on there. When you have something that looks like this with three lines that all cross each other, it's a little harder to pick out what the transversal is. So we're going to identify the transversal first and then classify each angle pair. So if I look at angle 1 and angle 3, the transversal is what goes through both of those angles. So in this case, my transversal is line L. And then we have to identify how those two angles are related. So angle 1 and angle 3 are on the same side of my transversal, and they are both above these other two lines, M and N. So we go back to our definitions. They're on the same side and on the same side of your two lines. So those have to be corresponding angles. So now let's look at two other ones. Let's look at 2 and 6. So angle 2 and angle 6. Remember, identify your transversal first, and that's the one that cuts through those two angles. So in this case, it's line N. And then if you look, they're on opposite sides of our transversal here. One's on the inside, one's on the outside. But they're inside our other two lines, L and M. So that makes them alternate interior angles. And then finally, let's take a look at angles 4 and 6. So remember, the transversal is the one that cuts through them. So in this case, it's going to be M. And then we have to identify what is going on with these. So again, they're on opposite sides of our transversal, but this time they're on the outsides of our other two lines, L and N. So these ones are alternate exterior angles. So we've reached the end of the lesson. You should be able to identify parallel, perpendicular, and skew lines, and identify angles formed by two lines cut by a transversal. Make sure you write down any questions you have, and we can go over it in class. Have a good night.